All right, class, we've arrived to the part where we can start using matrices to solve linear systems. In order to do that, we need to introduce what the coefficient matrix is. So the coefficient matrix is going to be the matrix composed of the coefficients of our system. So thinking of x being the first column, y being that second column, I'm just going to write down those coefficients. So notice how that comes directly from our linear system. Now, Cramer's rule, which was named after a Swiss mathematician, Gabriel Cramer, uses the coefficient matrix and determinants, right, two things that we are now familiar with, to solve a system of linear equations. So if we are given this system, we're going to let A be our coefficient matrix, and it's composed of all of the coefficients of our system. Again, noting that x's and y's are definitely lined up. If the determinant of our coefficient matrix is not equal to 0, this means we in fact do have a unique solution, and it's actually given to us by, I want you to take a note here. For x, notice how we swapped out the x values for E and F, which are the solutions to our systems, right? Those were the results. So for x, it's going to be E over F, BD, and we're going to take the determinant of that matrix. And then for y, we swap out the y values for the result of that linear system. And we're going to take the determinant of that divided by the determinant of A. And that gives us the unique system. So let's go ahead and try it out in a couple of examples. Before we go there, though, let's note that if the determinant of the coefficient matrix equals 0, this just means we don't have a unique solution. That means that we either end up with a no solution or we have an infinite number of solutions. Okay. All right, let's take a look at this particular example. So first, here's our linear system. We need to start off with our determinant, or coefficient matrix A, which is going to be given to us by 1, -7, -5, and 2. Okay. Let's go ahead and calculate the determinant of this matrix. So the determinant, remember we're going to go ahead and multiply 1 times 2 and then add it to -5 times -7. So we end up with -33. So now to solve for our x values, we're going to take x is going to equal the determinant, and now instead of writing the x column, I'm going to go ahead and replace that with 9 and -30. So 9, -30, and then I'm going to go ahead and write the y values, -5 and 2, all over the determinant of A, which is -33. So now we're going to calculate the determinant of that top piece, so 9 times 2 plus -30 times 5. That's going to give us a -132 over -33. When we go ahead and divide this, this actually equals 4. Now for our y value, we're going to have y equals, now we're no longer, we're still going to use the x value, so we're going to start off with 1 and -7, but we're no longer going to use these y values here. We're going to replace them with the values that our system is equal to. So here we have 9 and -30, all over our determinant, which is -33. So 1 times -30 plus -7 times 9, that gives us a positive 33 over -33, which gives us -1. This tells us that the solution to this system is 4, 1. -1, drop the negative. 4, -1. Okay, now this is a whole new concept, right? And it might be a little funky, so let's go ahead and try one more example. First, let's identify that coefficient matrix. It's going to be 2, 5, 6, and 1. Now let's go ahead and calculate that determinant. The determinant of A, that's going to give us a -28. Once we calculate that determinant, let's go ahead and calculate our x value. So our x value, remember, it's going to be that same coefficient, right? We're going to take the determinant of the coefficient matrix, except instead of writing down the x values, we're going to swap them out for the 38 over negative 3, which are the results of that system. And now we're going to divide that up over our determinant, negative 28. And so let's go ahead and calculate this. So the determinant of that top matrix, that's going to give us 38 minus negative 3 times 6. So 38 minus 18, which is 38 minus negative 18, which gives us 38 plus 18, which gives us 56, all over negative 28, which gives us a negative 2 for the x value. Now let's do the y value. So our y value is equal. Again, we're going to copy that coefficient matrix of 2 and 5, except now, again, I'm going to take the solutions and replace them with the y value. So I get 38 and negative 3. And that's going to be all over my determinant of negative 28. So let's calculate the determinant of this top number. 2 times negative 3 minus 5 times 38. That's going to give us a negative 196 all over a negative 28, which gives us a positive 7. So this means that the solution to this particular problem is negative 2 comma 7. Okay. All right, we'll go ahead and pause the video and try number 3 on your own. All right, take a moment to examine your solution that you calculated. Did you get the same thing? Did you get negative 3 comma negative 4 when you attempted that? Okay. So again, remember that we're going to replace out that x values, that x column, with the solution column. And then we're going to do that again for the y. So I've highlighted that there in yellow. All right. Let's try now solving systems with Cramer's rules with 3 variables. So it's going to be the same process. It's just we have an extra variable. So our coefficient matrix now is going to be a 3 by 3 system. And so if the determinant of A is not equal to 0, then we have a unique solution, and it's specifically given by, again, notice how x is swapped out for the solutions, right, of our system over here. In this particular case, we've swapped out y. And in this last case, we've swapped out z. We've swapped out z. So every time we're solving for that particular variable, we're swapping out that particular column for the column of the solutions. So let's take a look at number 4 as an example. We're going to start off with that coefficient matrix. So our coefficient matrix is going to be negative 1, 2, 3 for our x's, 7, 1, and negative 5 for the y's, negative 2, 9, and 2 for the z's. Here's our coefficient matrix. Let's take a moment and calculate that determinant. So remember, in order to calculate that determinant, you're going to take these first 2 columns and write them to the side. But I'm going to tell you right now that the determinant for this one is going to be 140. Okay. All right, let's go ahead now and see what we would get for our x values. So our x value, we are now going to go ahead and swap out x for the answers here. So we're going to get negative 14, 43, and 2. Then we're going to come over to the next column, and we're going to keep it 7, 1, negative 5. And then we're going to have negative 2, 9, and 2. And this is going to be all over 144. All right, let's go ahead and set up y. So for y, we are going to have negative 1, 2, 3. And we're going to have negative 2, 9, 2, all over 140. And we're going to replace those y values by negative 14, 43, and 2. Lastly, we're going to have the z's. We're going to have negative 1, 2, 3, 7, 1, negative 5, all over 140. And we're going to replace the z column with negative 14, 43, and 2. Now, as you can imagine, this is not going to be the funnest thing to calculate by hand, to calculate the determinant of three 3x3 matrices and then have to divide. So what we're going to do is I'm actually going to take this moment to show you how to do this with a matrix calculator. In class, I asked you if you own your own calculator. If you do, I'm more than happy to show you how to do it on your calculator. If you don't, no worries, we're going to be using technology. So we're going to go over to the Desmos matrix calculator. This should be included into your modules. So the way that we're going to go ahead and use this is we're going to go ahead and select DEET, which stands for determinant, and we're going to go ahead and hit new matrix. Now we get the opportunity to edit our matrix. We are looking at a 3x3 system, so let's go ahead and put in our values. So for our x value that we're going to be looking at 14, and then we're going to look at 43, and then we have 2. Here we're going to have negative 5. Sorry, whoops, not negative 5. 7, 1, negative 5. And in that last column is going to be negative 2, 9, and 2. So now that we've defined our matrix A, we're going to go ahead and hit the determinant of A is going to be equal to us as negative 700 that we can see right there. So it's going to be negative 700. We can actually go ahead and write everything out. So let me show you how to do that. So we're just going to do the determinant of A. Let's close that out. And we can now divide it by, we already know that the determinant of our original A, our coefficient matrix, was 140. So we can see that the resulting is negative 5. So let's come back over here. So we saw that this equaled negative 700 over 140, which gave us negative 5. All right, let's try this next one. And I can actually, look at that, I can actually change it. So we can come over here and change this back to 1, 2, oh wait, no, 2, 43. No, 2, that was right, sorry, I'm looking at the wrong thing. And 3. I actually think that this is a negative 1. All right, and so now let's change this second one to negative 14. This is going to be 43. And this is going to be 2. So we have a new determinant, right? Actually, it's kind of nice because it changed all the way through. And notice that our new answer is going to be negative 1. So our determinant of A is going to be negative 140. This will be negative 140 over 140, which gives us a negative 1. And last but not least, we have our z. So let's go ahead and come back over here. I'm actually just going to come back and change this. So I'm going to go back and change this to 7, 1, and negative 5. Now we're going to change this to negative 14, 43, and 2. And that one stays the same. So once we do that, notice that our determinant of A is 840, and then 840 divided by 140 is going to give us 6. So we have 840 over 140, and this is going to equal 6. So here are my values. So this means that the solution to this particular system is going to be negative 5, negative 1, and 6. That's our answer for that one. All right. Take a moment and try this one and see as far as you can get. And then you'll have all the solutions here for you in a second. So go ahead and pause the video and try this out. All right. how did it turn out? Is this what you got? The determinant of A to be negative 121 and your solution to be negative 4, 2, and negative 9. All right, hopefully that worked out. In case you didn't and you're still a little confused with how that came to be, let's do number 6 together. So we're going to start off by writing off that coefficient matrix. That coefficient matrix in this case is going to be negative 1, 8, negative 2, 4, 3, negative 1, 1, negative 2, 9. So this is our A. Let's go ahead and calculate the determinant of A. And we can come over here to the Desmos calculator to calculate it. So we're just going to go ahead and hit new matrix. We have a 3 by 3 system. So let's go ahead and plug this in. So we're going to get negative 1, 8, negative 2, 4, 3, negative 2, negative 1, and 9. So this becomes the matrix A. So we're going to define that as matrix A. Now let's go ahead and calculate the determinant of A. And so notice that I'm already given that the determinant of A equals negative 299. So we come back over here. We know this is going to be negative 299. All right, now let's go ahead and calculate the x value. So I'm going to start off with calculating the determinant. So I'm going to replace the x with the solutions. So I'm going to end up with negative 26, negative 19, 32. Everything else I copy from that matrix A. This is going to be all over our determinant of negative 299. Let's look at y. And y, I'm going to copy everything down that's x and the z column. Let's go ahead and now we're going to write the solution down in the y column. We're going to go ahead and divide this by negative 299. And lastly, we have z. So in z, we're going to do negative 1, 8, and negative 2. We're going to copy the x's and the y's. And then the z's we're going to replace with our values. There we go. All over negative 299. All right, let's go over to the matrix calculator over here. Let's go ahead and plug it in. So we have our determinant of A. I'm just going to add a new matrix. We'll call it B. That's fine. And let's go ahead and up the rows. So we have a 3 by 3. And then I'm going to be looking at negative 26, negative 19, 32, 4, 3, negative 1, and then I'm going to have 1, negative 2, 9. I hit enter. So now I'm going to take the determinant of B, which is negative 299, and I'm going to go ahead and divide that by, and actually just write it off as the determinant of A. And so we in fact do get 1 because they're both equal to negative 299. So let's go ahead and plug in y. I'm actually, in this particular case, I'm just going to change b. So I'm going to change this back to negative 1, negative 8, negative 2. This is a positive 8. Always make sure you double check those numbers. Negative 26. Here we have 3, negative 19. $32. Alright, so here we see that the difference, right? And actually, we can actually just call it this. Let's see what determinant of B is. Okay. So determinant of B divided by determinant of A is actually going to be equal to negative 7. But determinant of B alone is 2093. So let's write that down. So 2093 divided by negative 299, which is going to equal negative 7. All right, last but not least, let's come back over here. Let's go ahead and change B. We're going to change this column back to 4, 3, and negative 1. And let's go ahead and change this back up to negative 26, negative 19, and lastly 32. Okay, so we can see that the determinant is going to be negative 897 all over negative 299, which is going to give us a positive 3. So this tells us that our final solution is going to be 1, negative 7, 3. Yay. Alright, and that's it for that one. Alright, go ahead and take a moment and try number 7 on your own. Alright, did you get 5, 0, negative 4 as your solution? The one thing I do want to point out just real quick is remember that when we have zeros in the numerator and we're dividing by a number, that does equal 0. It would be very different if I ended up with negative 8 over 0, because now this becomes undefined. Now this leads us to have that discussion of why it's important that the determinant of A not equal 0, because we're essentially dividing by 0. So we don't want that. So hopefully that worked out and you got this one. Our very last example for this particular concept, right? Go ahead and try this out, and hopefully we get it, and it means we have a good handle on this. All right, for our last equation, or system of equations, sorry, we got that the determinant of A is equal to 144. We got our x value to equal 6, our y value to equal negative 2, and our z value to equal positive 8. Hopefully that worked out and you got that correct. If you have any questions on this, please reach out. And yeah, we're getting one step closer to being done with matrices.